All right. Welcome to.
Okay, well, thank you, Michael. This is the March 2025 Uniform Chicago General Meeting, and we have Michael Potter to do a presentation. He's titled "Seatbelts and Our Airbags for Bash." Take it away, Michael.
All right. Well, first thing I want to say is tip of the hat to Andy Lester because he actually named this presentation after I originally gave it in 2006 at Uniform. He came up to me after the presentation and complimented me, and then said, "Yeah, this presentation is seatbelts and airbags for Bash." And I immediately changed the title, and it's been seatbelts and airbags for Bash ever since. Um, so anyway, I'm Michael Potter. I'm president of Replatform Technologies and TAP Solutions. Replatform Technologies migrates mainframe applications to Linux. And so this presentation was inspired by all the pitfalls I found in Bash as I was converting JCL, uh, mainframe JCL to Bash to run on AIX actually. Um, it's so we're not going to focus on everything in Bash. What we're going to focus on is how to make Bash reliable. The context is using Bash for running production jobs at a large company or even a small company, things that run it at night, unattended, and need to report that they failed. Uh, some of the technique, all the problems I'm going to point out in this presentation are real problems, whether you're using Bash just casually or whether you're using it in production. So you don't necessarily have to follow exactly what my techniques that I'm pointing out, but it's important for you to understand where Bash fails and compensate in some other way in your scripting. Uh, so the the other company we do software for insurance companies, specifically mobile apps and web applications. And first thing, let's talk about why people use Bash. It's simple to get started because it's the default shell in a lot of Linuxes. I know Z shell is getting a lot more popular right now, and maybe someone will watch this presentation and decide they need to switch to Z shell because Z shell is a more robust shell. But Bash is simple to get started. It's actively developed and ported and fixed, so you're using current technology when you're using it. And it includes advanced features that we'll go over, including regular expressions. And one of the things in contrast with like Python and Perl, people might say they want to run Python or Perl as an alternative to Bash, but really Bash is really handy for piping commands together. And we'll show some of the pitfalls of trying to pipe things together in Bash and how you can get in trouble when you do that and how you actually stay out of trouble. So today we have the focused goal. Um, is one of my pet peeves with Bash is how it will fail just with no warning and no error messages. And so we're gonna because it tends to be very forgiving. And so what we're gonna do is we're gonna take those silent errors and we're gonna turn them into something where Bash will kick and scream when it fails. And also, I'm going to talk about if statements and how to avoid the syntax in Bash that is just problematic. So instead of learning all the nooks and crannies of Bash, I'm going to teach you what to avoid so that you don't have to uh, learn the nooks and crannies. And also, I'm going to show you how to define variables so that your very large shell scripts are more robust with not overlaying values in the inadvertently overlaying values in variables. Now, I've got a handful of scripts that we're going to use to demo. And so they're going to follow a pattern. So you're going to see me run a script and it's going to run just fine. And then I'll add some additional syntax into the script. And then you're going to see a hidden error become apparent. So many of you may see errors in these scripts. That's intentional. So this this script is what we're going to use for the first three demos. It has intentional bugs that we'll expose in the demos. I'll be showing it. I'm showing it to you now because it's going to flash up on the screen pretty quick. So you're going to want to kind of get previewed, have a sense of what it's doing, so that when as it's flashing up on the screen, you don't get lost. Now, this isn't an actually useful script. It's an academic script whose purpose is to demonstrate Bash features. But during the demos, we're going to pretend that it puts out, echoes a line out and to an output file, and then it searches all the command or all the running processes, finds all the processes that I own, and puts them into this file. And then another important element is it puts that it's finished. So perhaps if you don't see this line, then the script exited early. So that's important to pay attention to too. Now, setting options looks like this. So we're going to set an option, set -O, and then the option is going to be something that I'm going to have be set. So here we go. So this is the no clobber demo. So we're going to watch me run the script, and it no errors, right? Return code is 0. It finishes just fine. And now we're going to edit it, and we're going to add in the no clobber script. I apologize if it's not. There we go. Didn't hit the forward key good enough. So now I'm just going to slip that set statement in there. No clobber tells Bash to not overlay a file. Okay, now we're going to run it again. And now you see a couple of things here. It says, hey, can't overwrite an existing file. A couple of things bug me, right? It should just fail on the first error, because I don't want it to continue on lulling me with an error message getting buried in the output and I don't know to fix anything. I want it to fail immediately, and I want it to have a return code of 1. So let's see what I'm going to do to fix that. So I go in and I'm going to add the error exit command on here. So now we're going to exit when there's an error. Okay, now let's run it again. Okay, that's good. It's exiting on the first execution of it. Let's go fix that error now so that it's running. And so now I'm going to add in a remove so that file, I know it's just a temp file, so I'm going to remove it up front. And then I'm also going to append to that file on the second iteration so that I don't get a clobber there. Okay. And then we see it ran just fine. Exit code was 0. We have this beautiful script that has absolutely no errors in it. So I just dumped it out there, catted it out. So the slides will have that catted out script on it. Okay, so what did we learn? That no clobber is used to avoid overlaying files, right? We're going to get an error if we try. And error exit is used to exit upon the first error, so we avoid any cascading errors. And then what I didn't show, but what's really cool is you can do this with instead of um, removing the file or moving the file, you can add a vertical pipe and greater than, and then that tells it for this redirection, it's okay to clobber the file.
Is that
So
can there not be a space between those two?
I don't know, actually. It's a good question. So what I put it down here, I didn't have my slide set up, but instead of the remove and the echo, then we could just have this.
You
But I
should be
kind of
able,
go
I'm
ahead.
sorry, Mike, you should be able to have a space between the greater than sign and O, but you will definitely need to have the vertical bar and greater than sign as one computer word,
All
if that
right.
makes sense.
Yeah. I would expect them to have to be together, but you never know.
Yeah,
There's
but
weird.
the file name does not need to be contingent to that pipe sign greater than sign. You can actually have a
Yeah.
space between the greater than sign out because it's basically the reason why I say that's true is when you understand how the shell will parse the command line to submit it for execution. So definitely it sees the pipe sign greater than sign as a key word, for lack of better terms. But
Okay.
the output file.txt is a file name. So you're outputting the file. So, you can have no space or you can have a space. It makes no difference. Both will work.
Okay. All right. I'm going to move on to the next. Uh, Sorry, I have to get my cursor in the right spot for it to recognize my keys. So, okay, use to intentionally clobber the file. Okay, now let's move on to talking about piping commands together. So the output of command one is going to dump into the input of command two so that things can be piped together. So let's see what we can do to find errors with this. So we're going to add the pipe fail option in the script. So we just ran it. It's exactly the same as where we left off. And now we're going to edit it and add the pipe fail option. Okay. Now let's run it again and see what happened here is it exited early, but it exited silently. So it probably exited with something other than exit code 0. I didn't dump that out. So now I have to Google around and try to figure out what can I do try to debug this. Where is it failing? So I commented out the error exit to try to get some clue as to what I'm doing wrong. Now I get exit code is 1. Kind of strange. So I keep Googling around, looking for actually perplexity, using perplexity now, I guess, instead of Google. Trap. Now we're going to put in a trap and error and the add in the line number that it's exiting at. And so that's the additional command we're going to add to it. And now let's see what we get. So at about line 9, we're failing. So let's go tinker around in the script at about line 9 and see what's going on there. Okay, I think I see what's wrong. The PS command, I'm on my Mac, so I can't use the other commands. I have to use the Mac specific options on PS command. So let's see if that runs. Okay, ran fine. Let's cat out the script so the slides show it. Okay, let's keep going. So what did we learn? That the set pipe fail will unveil hidden failures. Uh, the dash O error exit can exit silently, right? It can just terminate the script without any error messages. But the trap error command and error can correct those silent error exits. And the line number variable is a built-in variable to bash that enhances error reporting for us, so we can report lines that failed. So let's move on to the no unset variable. So this tells bash to not tolerate variables that aren't set. So we're going to put that in there. Of course, I'm sure we don't have any variables that aren't set. This is only 4 lines of code. How could there be a bug? Right. So let's run it. And oops, USR is an unbound variable. So reminded myself, oh yeah, it's ER on not USR. Now let's run it. And it runs fine. It's a completely bug-free script. Now let's head the first 2 lines of that error output so we can see that it actually is dumping the process status into a text file there and dump out the script. All right. So what did we learn? The no unset exposes unset variables. So it almost never I would ever want to tolerate an unset variable in a script. So that one's a good one. All right. So let's look at the final script here. You notice I did something a little different. I put in the move command to save the backup to the back file. It's up to you how you're managing your system, how you want to not clobber files. All right. So, but there's some improvements that we could make to this. Specifically, I want to put all that stuff that I want in all my scripts. I'm going to put it into a shell script, a library that can be included or sourced into the bash script so that I have everything just the way I want it. Now, what's wrong with this is this dot would be too easy for someone to overlook or a new programmer to assume it's a mistake and delete it off or bad things or things like that. So I recommend changing that dot to a source statement so it stands out so anybody looking at it really can see it and it doesn't get overlooked. Then in addition to that, because this is the first thing in the script, stringent hasn't taken hold yet, right? So if we're sourcing in something and it can't find it, it's just going to throw an error and not stop because stringent hasn't been loaded yet. So you can add an or exit 1 on this line, and then it will exit if there's any problem sourcing in that file. Okay. Now this file is on GitHub. I'll give you that link in a minute, but let's take a look at it. So this is stringent as its first iteration. We're going to add to it here in a minute because it's instructive to add to it. And you can see I've added a couple of things. Error trace goes into subshells so that the trap error works in the subshells. And I didn't experiment with it to find out what the limits are, where it's actually needed. It's just a good idea to use it. There was no downside. So I put the error exit first so that if anything else in stringent, at least we would get it would error exit and not continue, right? So if something went wrong and that I had no unset, misspelled, well, I wouldn't know about it necessarily. I wouldn't see the error message. It might get buried. And then also I created a a function here because I'm going to add to it. In the next slide, we're going to expand this function. And so this function here, trap error, is here. Also, what that allows us to do is just call this function too, if we want to have an error or output the location of an error in our code. Well, let's and then these are more robust versions of the line number. So this will tell you where you were at in a subshell or in loaded modules, and we'll dig into that in a minute. Oh, there it is. It's on my POTMI, POTTMI GitHub account. If you go there, you can see the stringent.shell, the current version of it. And by the way, David sent me a update to that I put in there. It's in this one. It will complain if you just if you don't source it, if you just try to invoke it on its own without it being sourced. Now it will throw an error. And you can see that in the GitHub. Thanks, David, for that suggestion. Okay, so this is a little script here we're going to work on. And this is 5 lines. It's got sources in stringent, then it echoes out so we know where we're at in the script, so we know if we exit early. And so if we get this here when we run it, it's before going to fail, and then we fail at line 7, right? Perfect. This is perfect error. Let's change the code up so it's a little more challenging for stringent. So if we add a function in here to force, and then we change that false to calling that function. And so we're inside of a function. So let's test how that looks. And now we get before going to fail, then we get the start going to fail, and then we exit at line 5, right? Because it's 1, 2, 3, 4, 5 into the function, right? So that's not very good. We're not getting a good line number there. So let's see what we're doing there. And what we're doing here is we're forcing the failure inside of a subshell, right? So let's see what happens when we do that. And now we get the error that it failed at line 5 and failed.sh. But it continues to run. So we need to fix that. So what are we going to do to fix that? Let's take a look. This is our trap error as we started with this. And now we're gonna take that use case and we're gonna keep changing this trap error function until that test case works fine. So the first thing we've got it here failed, and maybe I've missed it a little bit. It's line 6 instead, but it's the same script. Now let's add in that if we're in a subshell and we detect that with another bash variable, we commit suicide, right? So we issue a kill on our own PID. And now we get a terminated message. We get failed at line 6 and we get a terminated because that was what's new. Now let's take care of that problem where we didn't know the function name. So now we're going to use the bash special variable for function names, and we're going to loop through to give a Perl style or a C style stack trace of where we are in the code. So we're at main in line 16, and we're in the going to fail function, and we're in the 6th line of that function in fail.sh. So this way, when we get really complex scripts, which are used in organizations that are really have their scripts have just grown crazy over the years. Drop this in, and now you can see where it's failing and zero in on the debugging. All right, and that's it. Now let's talk about that pipe status. So we added in that no uh, pipe status variable. And so if we run this, and I guess this should have had an E in it so that wasn't there. But it says now we can see that it's this PS command that's failing because it's 1 corresponds to the first command, 0 corresponds to the second command. Now, if we add pipe fail and we run that again, same command, right? This time, the aggregate $? will take, and Glenn might know this, I think it takes the first command that failed as the return code. And now let's run it properly. And we can see 0, 0, and 0, which is awesome. Then it's reporting out. And just for fun, let's run that again. And this time we get 0 because I'm demonstrating that's just transient. So now we get the return code from echo, right? So echo only has its own return code. So the lesson learned there is if you want to capture the pipe status, you have to make sure you're doing it right after the command where you want to capture it. So let's talk about that for a minute, how to do that. So as I previously said, pipe status is transient. So let's just get down to an academic example, true, false, true. This time we're saving it. So what you can do is you can declare an array that is the saved pipe status. And I like to put the aggregate $? is the first element of the aggregate of the array. So the 0th element is the summary status. And then you get an array of everything in that pipe status. So then you can query it later to figure out what's going wrong. So here we go. There. All right. And we'll have the slides so you can look back at that. All right. Variables. So we're going to do, I got some sound on it now, but so this is running an integer, and this is how you declare, going to do source in stringent so we can see what's wrong with this, and then run it again. So now we get unbound variable, which is very strange. I don't quite understand. 0 is an unbound variable, so let's try to figure that out. So to figure it out, let's just declare it. I want it to be an integer. Let's declare it to be an integer. Now we get the line changed. To look at that for a second and then realize, yeah, I typed O instead of 0. So now it's going to be a 0 instead of an actual integer. And now we get the value 10, which is what we got originally without the declare, but there was a bug in that code. So if you're going to have a variable that's an integer, declare it. Okay, what did we learn? Stringent. Stringent saves the day again. And use the declare -I when you want to have something as a variable so you catch non-integer values being shoved into there sooner. And Unset variables default to 0. So not very nice if you're trying to, for the guys like me who like strongly typed languages. Now, the other thing in there was the ability to do math. So $sign open paren is a handy way to do math inside of that, and then have it act like a string with whatever the result is. Okay, so let's go over some of the arithmetic syntax that you can use. This is the one that I just showed you. This is my favorite, just $sign open paren, do your math inside. Reason I like it is you can use it anywhere a variable is allowed, including in a string. This one here is the let command returns a 1 or a 0 based on the calculation. Excuse me. So this is used in an if statement, so you can test whether the calculation returned a 1, 0 or non-zero. And then the open paren syntax without the $sign, that's identical to the let command. It's just a shorthand way, so or for something that's just easier on the eyes syntactically. And then this abomination, if you try to do something like this, you can do it, but you're crazy. I don't know any reason why you'd want to do this. No space is allowed, and special characters must be escaped, and int I must be declared as an integer. And then you've got this, which is this syntax, which I've never seen in the wild. I just saw it when I was poking around for arithmetic syntax. That syntax been deprecated. Okay, now there are two more out there. So when you need to do decimal math or floating point math, then you can run your math as a string and pipe it into the calculator and have it return the value. Where you would use this is if you want to use decimal math or you want to use large integers. And one more, come on, there we go. This is eval. So what's interesting about this is if you have variables that you don't know, you want to substitute in different variables. Now I've got a slide dedicated to this on the next slide, so we're going to go over that. Go over it in a minute, but the eval says to run the interpreter on it twice. So the first time it runs through here, it converts $$ to just a $sign here and here. But it will convert this $sign char to a B. So then it's looking for a variable called int B at the next time it runs on the second interpretation. So let's look at, I've got a clear example of that here, and it's handy. And this is exactly how I did it for the mainframe migration. COBOL programs need variables set with a prefix DD underscore. So this is how it knows where to pick up a file. So you tell COBOL DD underscore and the 8 character names that the COBOL guys like to use equals, and then it would be the full path to a file or whatever that COBOL program needs to open. But I don't want to get into the weeds on that. Let's just talk about how this works. So we've got this function, and you can see here the value is the $sign is escaped out. So the first time through this code, it's going to create a variable called DD underscore Bob. And it's going to, the second time through when it evaluates it, this is going to be dollar value, and it's going to pick up builder. And so when we run that, we get the output DD Bob equals builder here on that echo line. Handy to know in some cases where you have to use your variables have to be variable. Go. Excuse me. I forgot I put this in there. So you can do, so how it's evaluating it the first time through, it sees this, and the first time through it sees this, and the third time through it sees this, or rather the first time through and second time through. Okay, variable formats. So here's how variables look like in Bash, but really you should think of them as looking like this, with $, open squiggly, closing squiggly. If you think of this as being what a variable is, and that the previous thing was just a shortcut for that, then a lot of this rest of the syntax that I'm going to start to show you makes more sense. So let's go through some of it here. There we go. Stuff like this where you can add other things inside of those squigglies and make it do cool things. So let's talk about local variables. So local variables in Bash, and why we want to use local variables is so that if you have a really large script, somebody may be accidentally naming variables the same. And so if you're inside of your own function, you can declare that variable local, and then you won't be overlaying somebody else's variables, and they won't be overlaying yours. So in Bash, local variables are weak, but they are useful. So, yeah. And what's curious about variables in Bash, local variables in Bash, they're not local to the function. They're local in that function and below. So the other functions can see them. And so you've got two ways to declare them. One is to use declare, and the other one is to use local. And I like to use local because it's more descriptive of what you're intending to do with that variable. So the $1, $2 variables are not scoped the same. Those are automatic variables that are created, and they don't follow the same rules that I'm going to be talking about. So let's look at a sample of this, what we're doing. And I guess I said I like to use local, but I guess in here I use declare in my sample. Okay, so on the first run, or what I did was I have a function that prints out all the variable names in here. So it prints out var, var1, var2, var3, so we can use it as a test case here. And then when we run it, here's that function. It just prints them out. And it uses this feature here that if the variable's not set, then it prints not set in there instead of the value. That's the colon and then dash is what tells it to do that. Okay, so now let's show that output. So on the first iteration here, we get variable 2 here is set to not set. And I'm highlighting 2. You can look at the other ones in the slide. I'm highlighting 2 because it's the most instructive. Now at this point, it's pair. And then when it comes back into function 2, it's 2. And then when it comes back into function 1, it's 2 again. It's still set at 2. So even though you declared it local, you still have to be careful with what the guys below you are doing in their scripts. And so I highlighted this one because that's the one that has a pitfall in it. All right. And then if we pop back out to the main function, we go back to not set. I'm gonna cough here first. All right, back in. Okay, so read-only variables are really handy. So let's say you've got your function, right? You've got this problem where somebody else is stomping on your variables and you don't know where it is. Well, as a debugging technique, or maybe as a permanent technique, you can set a variable to read only. So you can declare it with the -r as read only, or you can use the read only command to set it to be read only. So let's say you do a bunch of calculations. Now you've got your variable set. Now you would do read only. So the read only keyword is pretty handy because you can manipulate your variable, and then before you exit your method or function, you can set it to be read only. Now, obviously, it's a one-way trip. If it wasn't a one-way trip, well, it wouldn't really be read only. And you can use it with -i to create read-only integers. And read only can be used on system variables. So we used it on the process status variable for some new users who we wanted to keep their uh, um, keep them from changing their process status variables in their bash setup files, so that we would have a standardized command line for when they report errors. And I wouldn't do that to anybody on this call. It was really new users who were getting curious on what they could do. And we just wanted to be in control of that. And we used it for keeping them from changing their prompt. It's not documented as working, so user beware. All right. So moving on. I treat Bash like a programming language in my source code. I'm a C developer. I love C. I think in C. I like compiled languages. So I treat Bash like a compiled language. So you can do a syntax without running the script. You can do a syntax check on the script with a -n. So in any of our projects that use Bash, we have, and here's a sample how to do it in Makefile. So you do bash, syntax check it. If that succeeds, then copy it to the target file. And I might have those reversed, actually. I no longer use make, so, but it copies it. It will copy the script to the target location. After it passes a syntax check. Now, I'll warn you, that syntax check barely does anything. So it's not going to be anything you're going to catch a lot of errors with. All right. So there's a ton of ways to do conditionals in Bash. And what I want you to do is stop using a couple of these because they're problematic. So let's go through them. Command lets you run a command. This is handy. This one lets you do numeric comparisons. Let and single space are the granddaddy, or single bracket are the granddaddy of the if statements. We'll go through those in a minute. And test is just a command that test file, test the locate or syntax, excuse me, test the permissions on files and whether a file exists. So this is really the same as if command, but we'll go through that in a minute. and the if command. So here we go. We're going to declare the status, right? Because I told you we need to capture the status immediately after the command, right? And then we're going to test the status in an if statement. This is pretty ugly. And we also need to turn off the error exit if we've got stringent in place, because if Jim wasn't found in the password file, then the script would fail right there. So the graceful solution to that is to just do the grep in the if statement. So if Jim is found in the password file, Jim is a user. Okay. Now, if you really need to run it separately outside of it, then instead of turning on and off the status, the set error exit code, you can prefix the command with a bang, and then that command is the set error exit is not active for that command. And that has the, it's going to reverse the sense of this. So instead of 0, it's going to be, you have to reverse this too. So I would not recommend this. This looks like a great way to get into trouble with your logic, but it is handy to know that the bang will turn off error exit on an individual command. But if I ever did that intentionally, then there would be a comment up here that would say that, what I was doing with that. So what did we learn? We can do the +O error exit to turn off error exit if you need to turn it off in a certain exit section of code. The stringent.shell library does have a function to do that, so it's a little more like the syntax says what it's doing, but you know, this is kind of obvious too. So I don't know if I'd care about either one. You have to save $? To a permanent variable if you want to use it. And you can turn off error exit for a single command with a bang. And another thing is 0 is true and non-zero is false. So I like to think of it as 0 is good and non-zero is bad when I'm working with bash instead of true and false, because this is the opposite of almost every other language I work with. Well, every other language I work with. And we also learned that the double open parens is used for numeric tests. All right, so let's go through some gotchas. All right, what's wrong with this? The problem is 3-year-olds buy beer. So the reason is because this square brackets is a string comparison. So 3 is greater than 2. So the 3-year-old buys beer. And the greater than is a string comparison operator. If we want to fix that, well, okay. If we're going to do it with single brackets, this is bad because everybody buys beer. Because the greater than sign is a redirection operator. This would have created a file on the file system 20. Now, let's fix this one, right? So we're going to use the -GT, which is the numeric comparison. So now this sort of fixes it, but it fails if age is not numeric. And the double square brackets, they're for comparing text. So just use the double parens if you're comparing numeric. And it's good because it's specifically for comparing numbers. And the $ on age is optional, but I never drop it just for consistency. The other thing I'll add, is where these are good is if you need to mix numeric and string comparison, and the square brackets become good. All right. So now let's compare test. Remember that list of all the if statements and all the different ways to do conditionals. We've got test and square brackets. So let's do a little test. So if we do which on test, bin test, not surprising. Now if we do which on square bracket, so some people may be surprised by that, right? It's sitting there. And let's do an ls-i. So what this does, it dumps out the inode of those files. So those two files have the same inode. So what bash is doing is it is, when you're doing the if, it's running this command as though it's a command. Now I just lied to you because in reality, bash has optimized that out so it's not actually running this command, but it still has to have all the side effects of running a command that I just showed you with the redirection symbol causing issues. And Glenn, do you want to chime in? Am I wrong or right on that?
Repeat that again, buddy.
That bash has optimized this out so it's not actually calling out to the square bracket command in an if statement.
There's also a situation you got to check with your shells because that left square bracket can be a test for false or true condition. It all depends upon what it's hard linked to, if you understand what I'm saying. Years ago on what was it, the standard Bourne shell, I saw that left square bracket in the bin directory or user bin directory, and it was linked to the keyword false that was there.
Okay.
So
all right.
you just got to read the man pages.
Okay. All right. Keep going. So what? So the thing is, use the double square brackets. Just predominantly use that. Get rid of the single square brackets and save yourself some headaches.
The square brackets are great. It's just that one of the things is the single use where you don't have an opening and closed square brace is strongly discouraged in shell scripting because 90% of your population isn't going to know what it's used for. That's why sure that they're grouped.
Yeah. Well, I'll go through, make my case that people should not be using the single square bracket here. So this will be true if A starts with Z, right? This will be true if A is exactly Z asterisk. This will error if A is a space, has a space. It'll error if more than one file name starts with a Z. It'll be true if a file name exists and starts with Z and is exactly $. I can't remember what that is not quite. And true if no file names exist that start with Z and A equals Z asterisk. So it's just an edge case soup right there with that single square bracket. Now here is, so if you're going to insist on using those single square brackets, put everything put your variables in quotes, save yourself some headache, and I'll be going over quoting in a minute too. So the rules, use that only when you want to use file globbing. Should be rare. Use when you want to use math, numeric exclusively, and use the double square brackets for everything else. Okay, regular expressions. So this was introduced with Bash 3.0. They come in pretty handy. It's implemented as part of the double square bracket syntax, and it uses the operator equal tilde. And supports regular expressions, extended regular expressions, which includes parenthesized sub-expressions, which we'll go through. And so these can really help you parsing out. Regular expressions are a really handy way to parse incoming strings. So let's go through some of them here. So, so without regular expressions, this is false because it has to be exact. This is true because it's doing a globbing comparison of the string where asterisk is a wildcard. Now down here, this is true because we put in the caret to say the beginning of the line is the. We don't need any continuation here because it's just a match. Here it contains brown, and here it we allow for any number of spaces. So the space asterisk. This is how I do multiple spaces. Allow for multiple spaces. Quick brown, and that's true too. So let's get into how that's actually used. So, and specifically how it's used with sub-expressions. So right here, we would get a match, and all this code would do is echo out got a match, right? Very simple. But let's add in some parentheses in here. So when you write regular expressions and are going to pull out the sub-expressions, the first thing you do is you write it out, parsing out everything, and then you come back in and you add these parentheses because the parentheses are transparent for purposes of matching, but they're used for extracting a fragment of the regular expression out when it's matched. So when this runs, the whole thing matches, and so it says what we got here, the quick brown is what we matched, and it said the whole thing, the 0th element of the regular expression match variable, echoes out everything that was matched. But the stuff that's between the green parentheses, that's quick. Stuff between the red parentheses is brown. So this is really handy way to take an incoming string and grab out what you want out of that string, especially with more complex matching than this. And so that's how to use sub-expressions, but let's talk a little bit more about the pitfalls of the regular expression here, how it's used. So when I wrote this, I used a lot of Perl. Perl has really good regular expression handling. One thing I noticed was that Perl would complain if I handed it a bad regular expression, and Bash would not complain. And so I said, that can't be right. There has to be a reason for that. So what I dug in and learned, it returns 0 when it's a match. It returns 2 if there's no match. And it returns something else if the regular expression had an error in it. And so I piped in it took me a while to come up with a garbage regular expression. But this here is going to print out, it's going to call trap error and say there's an assertion check that there's a expression in the regular expression. So it's calling my trap error from the stringent command. I think this exit 1 would be redundant because I think calling trap error would actually, I think maybe it would error. I'd have to check. Now it's been a while since I looked at it. All right. Okay, so now let's go through some gotchas with the copy command. And this applies to a lot of commands. So this is going to fail if the source file has a space in it, right? Because then it's going to say, oh, copy source file, but there's a space in it. So you gotta add quotes in there. And I apologize, Keynote changes up the quotes. So these aren't the actual ASCII quotes that's required, but I'm too lazy to try to get it work. But this is broken as well if the source file name happens to begin with dash. Now, certainly that would be rare, but it's not impossible, especially if you're dealing with files that originated on Windows. You know, you never know what those guys are doing. And so to fix that, add a dash dash here. Now, this isn't necessarily documented in all commands, but the dash dash syntax is part of the GitOps library. So even commands that their man page doesn't say they support this, it's likely they actually do if they're using the GitOps library.
One of the things that I would like to interject, Mike, if I may,
Sure.
one of the things that is terrible in the Unix profession and Linux profession is when you first see the fundamentals of learning Unix, it says command name options. That is the biggest piece of garbage there ever was. If you were to do the following and understand the command synopsis where it's command name, in square braces, options, in square braces, expressions, in square braces, file names, you start to understand this because one of the things that would work if you have a dash as in front of the file name, if you do copy space dot slash tac file name, that will work because the fact that you did a dot slash, it indicates that you're specifying a file, if that makes sense.
Okay.
A good example
Yeah.
is years ago when we had with the lost and found directory, if you do in the lost and found directory, the naming convention of these lost inodes was # inode number. Well, if you say file space # # file number, you get an error because the shell interprets that # as a shell comment. When you do file space dot / # the inode number, it interprets it as a file through the shell
Okay.
interpretation process.
Okay. All right.
That's just
Learn
good
something new
information
every
to
day. Yeah, right. Well, there's a fourth item here. So the no clobber feature in Bash, copy doesn't know about that. So if you want to use, carry in the no clobber, if you're worried about clobbering something, or you think the destination doesn't exist, and you just want to force that, you can add the -n on the copy command to prevent clobbering the destination. All right, on to quoting. So I'm bringing this up so I wouldn't recommend, you don't necessarily have to memorize these, but you can know they exist so that when you want to use the certain um, uh, use like this is real handy to use hexadecimal. So the $ single quote, it doesn't do any variable interpretation, but you can convert a hex code to the digit. And I used A, but this works for if you need to put hex codes in your bash script and you don't want any hex code in your source file. Any binary data in your source file. So you can do $ single quote \hex, put it in there. So it is curious. It escapes out the slash, but it doesn't know about variables inside of there. All right. So my quoting recommendations is quote liberally, because extra quotes are likely to cause a consistent error, and missing quotes are likely to cause inconsistent behavior. And your safe exceptions are within the square brackets and within double parens. And integers defined with the define dash I. All right, let's talk about handling undefined variables. So you saw this earlier. So this is how we say, we tell it, set a default, have a default value for the variable if it's outputting. And so the ones, this simply returns word if it's not set. It doesn't set the parameter, it just returns it. This one returns word if it's set. And I haven't found a use case for this yet. Somebody told me one, and I wrote it down, and I tried to read it. I couldn't understand it. They seemed pretty convinced there was a legit use case for the when it's set, return something else. Now this is fun because it's handy to use because it not only returns word, it also sets the parameter going forward. So this is handy syntax at the top of a script. In this one here, if the parameter is not set, then it prints this message and exits. Okay, so that was a colon. And so the same thing, the unset or empty variables, this is if you want to tolerate a variable with a space in it as being set, which to me as a C programmer, right? A variable is set, it's not null, but Bash has different syntax for that. So unset and empty and unset. So this is for unset variables. All right. So let's just use that in an academic script here. So the purposes of the script is just concatenate year, month, and day together, and passed in from my date, and do minimal checks to see if it's broken. So if the year is the required for the first parameter, but month and day are not required, right? So if they passed in something that's unset or empty, then set it to 1. So it would be January 1st, 2025, right? If I called this function, do some minimal checks and then echo that out. So this would be an academic example of how that's used. All right. So substrings. So if you can do a lot with substrings in Bash. And the reason I point these out is if you have simple ways to do things in Bash, then you're less likely to be having to write complex code, and your Bash scripts are more robust. So if we have this, we can do the substring from the 0th element for 3 characters, grab the, and just to show that it's offset. So 4th character, 1, 2, 3, or 0th, 1, 2, 3, 4 for 5 characters. We get quick. Now, what's fun about this is it supports from the back end here, 9 characters back from Fox, but this space is required because otherwise it's going to be the confusing for the unset variable syntax. So really cringy that they had to do that, but I really like going backwards from the end of a string, so I'm glad they found a way to accommodate that. So, and then if you leave off the end one, then it goes to end of string. So substring by pattern. So we can remove a pattern from the contents of the variable with these commands, and how you can remember them, that this removes it from the front this once, this removes it from the back once, And then the other two are as many as possible and as many as possible. Now you can remember that the pound sign is removes from the front is this little jingle where number one, because we give 110%, or you can just note the location on your keyboard where the pound sign is to the left of the percent sign. Okay, so let's do some.
So I remember it because a pound sign is a comment character.
So it's at the beginning. Okay. Anyway, here's using this as input. So we're going to remove wildcard slash as many times as possible, right? So this is how to remove the directory and just end up with the file name. Here, we only want to remove one extension here. So the percent sign is not greedy. It's only going to do it once, period, star, and then we've removed one extension. So I intentionally put a file with two dots in it to demonstrate that. Then if you want the folder that the file is in, use slash star. And you want to remove the leading slash from it to remove it from being a full relative path. Do that, and I just show what happens if you were to do %%. You'd end up with the root, the very root of the file name. Okay, search and replace. I love this because it's, this is the kind of stuff we can do in Perl, and it's nice to do it with Bash. So, okay, I guess I don't know what's wrong if it's if I accidentally deleted a slide or what, but I guess it's this simple, pattern and replace. Oh, maybe we got it. Okay. So we've got this string and we can replace the with and we get a fox jumped the dog. But if we put two slashes, then it's going to replace all of them that are there. So a fox jumped a dog. But if we want to get rid of it, then we just drop the replacement and it goes in. Now you can see here I put a space in. So this isn't THE, it's THE space to make sure. Otherwise, I would end up with double spaces in there. Okay, so Xargs, when I wrote this thing, grep was not as powerful. So today, you can use grep-r to recursively go through files in a folder. But sometimes you want a little bit more control on what files you're trapping out. So you could start out with this, and it's just going to grep the files in the folder. But if we want to traverse the whole hierarchy, then we need to do a find. So we do find type F because we're only going to grep files, pipe it into Xargs. Xargs is really smart. It concatenates all the file names on grep, and it's smart enough to know when you're going to exceed the limit of the operating system, and it will invoke grep multiple times so that it can not exceed the limits of the operating system on number of files or length of file command line. But what's broken on that is our old friend file names with spaces in them. If we do this, then grep is going to get get the files, the folder names and files screwed up and not be able to actually open the files because they have spaces in the name, and this thing is dumb. It breaks the list up by space. So what we do is we tell Xargs, don't break on space, break on null here. And then we tell find to put a null character in between each file that it finds. So these two commands work in concert here. Without one, it would mess up. Without both, it would mess up. And so what's crazy about this is if your find only has one file, or if the last invocation of grep only had one file, it doesn't prefix the output with the file name. So let me back up a second. When grep runs on multiple file names, it prefixes the matches with the file name that it found the match in. So in order to fix that, we added /dev null. So there'll always be at least two files names on the grep command so that it will output the name of the file that got the match. Now, where that can be handy is if you're generating your own list of files, or you've got some complex command that's building a list of files, whatever it is that's building the list here, then you can use translate to translate the end of line character to a 0 and make use of the xargs -0. Now, I freely admit that grep does a lot of this, but sometimes grep doesn't do exactly what you need. So having xargs and knowing it exists and knowing how you overcome the spaces is the important takeaway on this. That for running any number of commands, not just grep. You may be running a command that is not as flexible as grep, and you want to use the -0 option. All right. So I did this presentation to a gentleman who was teaching at a community college, and I'm not going to mention his name because I don't have permission I didn't tell him I was going to mention his name, but he sent me this. And what it is it's the command prompt that will add a green check mark or a red X based on the previous command failing or succeeding. So this helps you when you're running commands to just instantly know if that command failed previously. And this will be in the slide deck that Wayne will post on the Uniform website. So you'll be able to grab that out of there. Now, the other thing I do is in my command, I use a # as the prompt. And the reason I do that is if I ever accidentally cut and paste something or cut and paste too much off the terminal screen and then paste it somewhere, the bash interpreter sees it as a comment and just it silently falls through without rerunning any commands or causing any issues. All right, let's move on to unintended subshells. So we've got probably 10 minutes left in the presentation here, so we're doing pretty good on time. Unintended subshells. So here you can see in Bash and Korn shell work the opposite on this. So this is really important to be in tune with if you're converting things between Bash and subshell. So what I would expect to happen is come through, count up all the lines, and we would have a count number here that matches the number of dots we see on the screen as it's reading the password file. So let's see what happens. Okay, count to 0, right? Because we're inside of a subshell here, in here. And so this variable is fresh every time it's running the command, every time it's doing this. So how do we fix that? Well, this is the thing on the useless uses of cat that people get beat up for all over the internet whenever they post their script and somebody uses cat and pipes it into something. This is in that category, but this is academic. It could have been any command there. What you do is you redirect. One way to solve this is you redirect that file into the while statement on the done command. I don't like this because I like to see it up front, but that's what you need to do to make sure it works. And then that's going to work on both Korn shell and bash. But what happens if you need to run a command right there? Right now I'm using cat. No one would actually use cat for this, but let's say there's something more complex that you need to put in there. This is, and I forgot the name of this syntax, but it's less than an open paren. And when you do this, internally, bash is creating a named pipe here. And then it's putting the named pipe on this command and routing it into the while statement. So behind the scenes, and what I've observed, at least on the machines I was on, I think it was AIX, it could have been other things, it creates that named pipe in the /temp folder, and it does not delete it. So if you see some strange files out in the temp folder, maybe somebody's using this syntax in a bash script. Oops. Now, let's say if we want to count the number of shells that have, or number of user entries in the password file that have their shell set to false, right? Now we know 20. Something a little more complex in
Mike?
there that justifies the named pipe.
Michael?
Okay, Glenn. All right, tell me I'm wrong. We happy to accept corrections. What's going on?
Michael,
Yes.
process substitution is what it's called.
Oh, okay. Thanks, Mike. Process substitution. Okay. But it's creating a named pipe, so it's that simple internally. Thanks for Googling that or looking up. Maybe you knew, right? I don't know. Okay. So now that I've convinced you guys that stringent is the greatest thing since bash, I want you to go out and edit all your shell scripts and add stringent into any of them that don't already contain stringent. So I wrote this little script for you guys to run that it'll go out, do an ls-shell, find all your shell scripts, read each file name in. If that file doesn't contain stringent, then execute vi on the file so then you can edit it and fix it up. Well, if you do this, it's going to break. And the reason is the ls is pumping standard into here. It'll read the first file name. When it starts vi will read standard in and suck it all in, and your file will be filled with garbage. The solution to this is to tell while to use a different file descriptor. So we can use the third file descriptor here, pump it into the third file descriptor, but here, translate it back to standard in for the read command. This is handy to know this is possible for any number of issues where you want to have different commands reading um, uh, reading standard in, different standard ins.
Question.
Sure.
The stringent command, is there is there a consistent place where you would insert it?
I just put it at the top of every,
If you
at
put
the
in the
top of the
top,
main script,
one
top
of
of the
the
main script.
okay, one of the quicker ways to not have to conflict with the issues with the VI editor, you might want to consider creating a description file for sed that it reads, and you can use the sed minus I option with the minus F option with your sed file to go ahead and do the insertion. That probably might
Yeah.
be cleaner.
Yeah. I wouldn't trust sed to edit all my shell scripts. I would want to put my eyeballs on it, but
I hear what you're saying.
yeah,
However, I know your argument. However, if you
yeah,
were back in the 90s, I did a lot of sed filters for updating the programs. Now, the thing that ends up happening is if you want sed with the minus I option, automatically creates the file. But if you provide a extension, it will create a backup extension for you so you have a backup file in case you have to go back to it. Just
okay,
something to think about. I'll provide an example of that in the
yeah. In your
regular session presentation for next
yeah,
month.
yeah, it would be a good one for regular expressions because I'm sure you're going to show some said stuff. All right. Well, that's it. I'm gonna. I think should I stop recording before we ask questions?
I don't know. You might want to include questions and answers that you respond to from the audience. I think that might be beneficial.
Depends on if people are shy. I'm trying to figure out how to stop the recording now. Pause and stop recording. Okay, I'm just going to stop it.